ladies and gentlemen, it's time now to open the imaging session. So we are very pleased to welcome three different speakers. Vincent Dubois from GSK, Mr. Cox from Histogenix, and Wouter Christian from Microtechnics. So Vincent Dubois will open the session. Please, Vincent.
So hello everybody. So my name is Vincent Dubois. I work in the team of in the EasyLab team of GSK, and we developed image analysis systems for the laboratory in the R&D department. So I will explain to you why we have designed multi-application systems for to answer the needs of the different laboratory in GSK. So here, just the agenda to follow the presentation. I'll start with a short introduction, and then we'll talk a little bit about what is a global layer management, and what is the key elements to take in account when we talk about this. We have also a topic about the light source and camera calibration, which is very important when you have multiple systems. And the teaching and reading concept, that is a very specific application that we have developed in the team, and that is really very useful for the users in the lab. And to close the presentation, we'll talk about the benefits of the multi-application design of the systems, and with a short conclusion. So first, introduction. We'll talk here in this presentation why we have been driven to develop multi-application system, and how we did it. So the story starts everything with the same thing. The scientists come to you when you are a support team, and he asks you to take a picture of his test, whatever it is. So here you can see you have spot. Cell-based, they say. It could be also agar overlay, whatever you can do in these labs. You can take the picture for him, so that's a good one. But the next step will be, can you measure what I can see, what I have what type of information I need to take from the picture? So it will be a measurement, a counting, depending of the needs. And when you have given the service, every time is the same, can you go further for me? So can you take the same picture of all my tests? So you have to automatize the test. You have to choose the right acquisition setup, microscope or macroscopic. And then, okay, now you are at the end of the project. The project is going further in the R&D process. You are now in the preclinical, for example, so you have a huge amount of samples to acquire. You need to robotize the loading of the acquisition device. And some issue could come. You have to manage the robot, you have to manage the different parameters that you have to use for the microscope and so on. But when your system is well designed, a lot of people now is using it because you have more and more tests to read with your system. And if you have more people when using the system, you'll have also more data to manage. And everything together could become really a nightmare. So you have to find a solution to manage very efficiently all these, from the picture till the data and the result after that. So what we did, first we chosen to integrate our system to control how the different users will use the system. And you can have one type of system, but you can have different types within the same automation park. And in front of all the systems, we have added a global layer manager with the two specific tools I mentioned in the agenda. First, the calibration and the teaching reading. And when you take the complete solution all together, with this, you have really a very well working solution. So, the global layer management. One of the principles that we chose and when we developed this global layer management is to work with acronym. The acronym is something that is really common for everybody. Everybody knows what is an acronym, but we've chosen to use it in a different way. An acronym, behind an acronym, so short name, there is a lot of information for the scientist. What kind of test I did, what kind of support I use to perform my test, what type of, is it a virus or a bacteria, specific conditions for my test, and so on. But for the automation side, there is also a lot of information. What kind of system I have to use? What is the acquisition parameters I have to use for this test? What is the analysis parameters, the robot position, and so on. So a lot of technical information for the automation part. And when we talk together, we can use the same acronyms, and everybody can understand each together. That's really one of the key, and we use it now for several years, and everybody is talking always with the acronyms when we talk about a test on a system. I said that it's more than 10 years of development, and that's true. We started, in fact, working with a global layer manager in 2003. A very basic one, but very robust. More than 1 million samples treated with this one. And from 2003, we will just decommission this one within a few weeks. So this one really did the works. But during the years, we chosen also to improve the global layer management. We first started with commercial product from Zeiss. Okay, it did the job, but we were not really fully satisfied. So we decided to come back with an internal development, something that we call stream. But it's hard, it's very hard to maintain. When you do this kind of development by yourself, you have to think about a lot of side effects. Let's say you have to deal also with the IT environment, you have to deal with the migration of OS and so on and so on. So that's a very huge job to do when you have to maintain this by yourself. That's why finally we came back to the commercial product, which one is now developed by Microtechnics, and the next generation will be the Icarus, the one you have seen on the booth of Microtechnics, which can be used also for image analysis systems. So now a few words about the light source and camera calibration. Why is it important? But everybody knows that when you use an analytical system, you need to calibrate it in a different way. You can use a reference plate, or you can calibrate it by the supplier with specific instrument. But here, we can calibrate our image analysis system without any support, only using a reference picture, a digital reference. Just like I explained to you. First, we have a camera. Whatever, the camera is connected on a microscope or just with a lens. That doesn't matter. You have a camera and you take a picture of the light, only the light. Here you can see the picture is not perfect, just a little bit of vignetting, so, but we can correct it. And we compare this picture with the reference picture located on the network. By doing this, we can calculate adjustment factors for the camera. We send back these factors to the camera, and then we can have exactly the same picture as the reference. It means that with this calibration, you can control how you will acquire your picture during the time on the same system, but also between different systems, wherever they are located, because this reference is available for all the systems together on the network. So really the benefits of this type of calibration is no physical reference. You don't need to revalidate your reference each year. Most of the time, that's something very difficult to manage because you need to have two references, because when the first one is going back for revalidation, you need also to continue your job in the lab. So you need two references, so it means that you have two support to validate and so on. That's a lot of also of paperwork and side work to manage. So no physical reference, that's very important. As I said, you can share the same digital reference between the system, even if you are in a different country. So it means that, for example, you can read one plate here in Belgium, you can read another plate in the US, for example. You are sure that you'll have exactly the same result. This calibration is very fast, and we can integrate this process in the routine. So it means at each run, you can launch it. It's less than 20 seconds. And you have also data to evaluate the quality of key components of your system. Of course, in imaging, camera and light are very important devices, but you have here the possibility to evaluate the quality with data. Teaching and reading concept. The teaching concept is, in this principle, really basic. You can train the application to recognize your specific object. Specific object could be CPE, bacterial colony, but you can train the computer to be able to recognize what is specific or not. We've chosen also to design this application to give the possibility to the scientist to define by himself the image analysis parameters. Image analysis parameters could be quite boring for non-initiated: dynamic threshold, open, close, scrap, kurtosis, fast Fourier transformation, and so on. Wording that for most of the people doesn't mean nothing. But with this type of application, you give the opportunity to the scientist to transfer, let's say transfer his knowledge into the application. We have also developed the application of the click and learn principle, very easy to use, and all the parameters will be centralized into the global layer management. And because the acquisition is calibrated, you can use the same parameters for all systems. So here you have a short video about what is the application teaching. So you see, just click on what is a colony, and the parameters here will be automatically adjusted to select. Oh, I think that I stopped the video. Okay. Okay. So you click and you add the colony you want to choose. You open range, and everything is inside the range is automatically selected in gray. Very fast, very easy. You do it on, let's say, between 5 and 10 wells on a 96 well plate, and I would say that 95% of your colony will be selected. Fast, easy, and all the parameters centralized. That's for the teaching. But you tell me, okay, now I have all my parameters, but what will I do with my parameters? I have to include it now in the routine process. So I have to go now to the reading. I will use the acronym, as I said before, and as technical parameters behind the acronym, I will link my set of parameters for the image analysis also. And in the reading, I also include the instrument configuration, and so in this way, I have all my parameters to be able to launch a reading of, let's say, 100 or 200 plates, if you want. So for the reading, it's just succession of all the well by well, and I will analyze and count how many here colonies I have in my well. And you can do it on colony, on CPE, on immunospot, and you can mix it on the same system if you want. That's possible because all the parameters are managed into the global layer manager. Okay, what are the benefits of the multi-application design? First, by centralized management of all the parameters that you can have regarding the use of image analysis systems. You can also control the capacity management of your system because you have the audit trail, so you can extract different data from the database. I would say metrics about the use of systems, statistic data, the percentage of use of the system, the MTBF, so mean time between failure. It's very important. The number of users by system also, you can control and justify also the investment in automation, because if you can see that the system is only used at 20%, you can say, no, you don't need to buy a new one. I have a multi-application system. You can add your application on this one because I have the possibility to do. And also, it joins also the sharing of the system. Do you have a common interface? It means also that you can drastically reduce the time you spend for the training of the people. Whatever is the application, the test you have to read on the system, it's the same interface, it's the same process. You also have the quality management of your system with the calibration, and we have standardized the process with the teaching and reading application, which is common. It's a common process to all the lab tests. We have automatized since now. The system is not dedicated to one project. It's cost effective for sure. It increases the return on investment also. But when a project is stopped, you can easily reallocate the system to another one due to the versatility of the system. You can read different assay technologies on the same system, bright field, fluorescent, episcopy, and different lab assay within the same run can be launched in one step. It means that you can have a first set of plates with bacterial, with CPE, and a second set of plates with ELISpot. You fill in the system, everything is managed by the global layer management, and at the end of the run, you'll have all your results well separated and everything managed by the GLM. So as a conclusion, with this design, in fact allowed us to set in place what we call the cloning strategy. It means that because you have multi-application system, you can clone it exactly. It's always the same systems, even if you have different analysis on the system. So we can clone the system. We can do it for image analysis, but why not also for liquid handling? And we have to clone because we have to face more and more demand coming from the department and different department also, and to answer also different business needs, but always with the same system. And because everything is standardized, we can transfer to our partners our expertise and our governance also to let our partners perform the installation, the validation, and the life cycle of the system. Because it's always the same, and because everything is standardized and controlled by the GLM also. So it means that for GSK and for our partners, we have a quick win situation, and also quick win situation also for our customer, internal customer. That's one of the force of the multi-application design. And the second one, what we achieve thanks to this design, is that we have now a system installed, let's say, across the world. We have millions of pictures right now. I stopped to count. There are too much. We have around 350 users, 33 running systems at this time, but within 15 years we have developed around 70 systems. And we are present so in 6 countries across 3 continents with only 5 automation resources. That's quite reduced. And also with the support of our partners, as explained just before. So the multi-application design is really important for us. We have developed it along several years, but finally, I would say that now we are close to reach one goal, very important. And this goal, if I can, let's say, rephrase the famous brand sport, I would say this goal is just automated. It's very easy now to install a system, develop the specific application depending on the needs of the lab, and put it in production. Very easy. Everything is controlled. You have a control environment with your GLM, and it's easy to deploy it anywhere you are. So I would like to also to thank you two people. If you have some question after, there are 2 people of the team here, David and Daniele, here in the room. So if you have some question, you can also ask them. Please, guys, if you just stand up so we can see. Thank you. And I'm open to a question.
Thank you very much, Vincent. We have time for questions. So, who wants to start? So, I just have a question concerning the new proposal from GSK scientists. I think there are 350 different users. When you have new ideas or when they want to modify something in the system, how do you manage that? Is that complicated? Is that easy? What's the interest of the process?
First we will analyze the request with them, depending on what they want. And we have different solutions. If the configuration that we have for the hardware, it will be very easy to develop the reading with them. And we have 2 possibilities. We can develop by ourselves the image analysis process, or we can ask our partner to help us if we have something very specific to develop. But this process is very well known. We use it now for several years.
And do you have to meet them physically, or you can develop?
Yes, it's very important because, in fact, we are the link between the scientist and the supplier itself. So the contact with the lab, the scientist, is very, very important to understand what he wants, but also his constraints he could have in the test. And finally, at the end, because people know who we are and what we can do for them, they call us from the beginning when they develop the test, and we develop the test together. So they take in account from the beginning that there is a technology to read the test, and they will not develop the test without the technology.
Just a simple question, a practical one. You talk about millions of pictures. Mm-hmm. Do you keep them for a limited period of time, or do you store for?
Because we are in a pharmaceutical environment, we have to follow a global retention policy. And it could be, when you are in QC, only 5 years, if I remember well, but it could be 65 years for the maximum.
Okay. Do you compress them, or
how many
terabytes do you need for?
Just to give you an idea, it's between 10 and 50 terabytes a year of data.
Any more questions? Okay, so thank you very much, Vincent.
Thank you.